So today's video is sponsored by The Bay, also known as BAE Systems, which is definitely what you were thinking. They do lots of things like building boats and aeroplanes and submarines, so perfect fit for me, really. When you think Charlieissocoollike, you think submarines, don't you? It makes sense. Well, actually, they also do a roadshow here in the UK where they tour schools and try and inspire a love of science in kids. As part of that, they have a bunch of cool experiments that they do on stage, and they have been nice enough to lend me some of their experiments so I can play around with them and show them to you. So yeah, let's get experimenting. All right then. Hello. What we have here is a bell, and it's in a bell jar. The jar looks like a bell, and that's why it's called a bell jar, but it just also happens to have a bell inside it. You don't always have to put a bell in a bell jar. You know, you can put whatever you want in whatever you want, as long as it's consensual. And this turns on, doesn't it? There you go. That's the sound of a bell. It's quite annoying, isn't it, Gideon? Yes, it is. Gideon's my cat, just in case you're not aware of the full context. So you can hear that relatively well while it's underneath the bell jar. But what this experiment is designed to show you is that sound only can travel through air, which is what this thing is for. This is a vacuum, like a way less efficient version of my vacuum cleaner. So what we're gonna do is we're gonna try and use this to take the air out of there, and we'll see what happens to the sound of the bell. Just attaching it there. See, you can't hear the bell, because all you can hear is this thing now. Let's just wait a while for the air to come out of that jar, and then we'll check back in. See, now, really all I can hear is this, it's this thing. Let's turn that off for a moment. You can still hear it, probably because there's a gap in the bell jar somewhere, but if we let the air back in, still annoying. Alright, that one did work perfectly, but hopefully it gave you an idea of what was going on. Let's try another, shall we? Oh, wow. Oh, God. So, a little bit less high-tech than the last one, but still very cool to promise. Before I show you, before your very eyes, how I can make this glass stick turn invisible, first, we need to talk a little bit about refraction. Everyone loves refraction. So what this is when light travels through a specific substance like glass or water, that light is slowed down a little bit and it causes the light to bend. This is why when I put this little glass stick inside of this bowl of water, it kind of looks like it's coming in at the wrong angle and looks a bit bent at the bottom, and that is because of how the glass and the water are bending the light. However, what might happen if we were to put glass inside a slightly different substance, like glycerin? Really thought that was gonna ding then. Why is it not? There's another experiment to be done there, isn't there? Now, glycerin is really annoying and sticky, but the interesting thing about it is it has the same refractive index as glass, which means it slows down light at the same speed that glass does and makes it bend in exactly the same way. Well, pretty much exactly. It's exact enough anyway that if I am to put this glass stick inside of the glycerin, you can see that it does, well, you can't see it. I mean, you can see it if you're me, and if you're like this, and you're looking really closely, then you can vaguely see it, but you aren't going to be able to say anything, are you? See, I just explained it, and I'm already just like, how the hell does that work? That's refractive indexes for you. Okay, last experiment. So what I have here is some sand, a little metallic plate, which is attached to this machine, which will create any frequency I want it to. It's also pretty annoying, isn't it? So what I need to do is I need to just put a little sprinkling of sand onto the plate, season the plate, and then there are some specific frequencies I can hit with this that will make that sand turn into a lovely pattern, which will let us visualize sound. I just have to find out what those frequencies are. Gideon is well pissed off at me right now. I think I need more sand. Heavily season. Ooh! Oh, look at that! Look at that one! Oh, something's moving. Let's get some more sand on that. There's something happening there. It's not quite as impressive as I was hoping. God, that is so annoying. Oh! Oh, look at that! It did it! Look at that! What are we actually seeing here? Well, this is the sound that is coming out of the center. It's causing this shape, this pattern. So the higher we go, the more intricate these patterns will get. Come on, show me this good stuff. I believe. Ooh! Ooh! Woo-wee! There it is! There's one! Alright, I'm definitely gonna stop that one there, because Good lord, that hurts. I hope you enjoyed that. I don't know if you really learnt anything, but I had a hell of a lot of fun, especially with this one. And that's it for today. See ya. Goodbye.
You've just had the almost imponderable joy of watching Charlie Is So Cool Like, which makes you like cool.
Thank you very much for watching. If you haven't heard, I am writing a fun science book at the moment, and I talked about that in my last video, which you can find there. And if you've been missing me generally, then I will throw you once again to my other YouTube channel, Serial Time, where you can see me mess around with my friend Jimmy. Let me know as well if you enjoyed seeing me doing fun science experiments for a change, because it really is a new thing for me. But if you dig it, I will do more. I'll find a way. That's all. Thanks again for watching, and good. Not bye, just good. Good.